Thank you for having me here, and thank you for PDF Kiev for giving me the opportunity to actually talk about something that I'm really passionate about. It's kind of a squishy subject that lays kind of at the bottom of the more practical stuff that we're talking about, and it's the relationship, the trust relationship between human beings and algorithms. So, I mean, the big question from the beginning of the presentation is, can we trust algorithms? And spoiler alert, no. Also, we can't help but use them. So I guess, the presentation, it's good that we have some things to talk about. The way I'm approaching this subject is from the perspective of information exchange. I mean, obviously one of our most important evolutionary traits. Thing is, we have always found ways of separating giving people, specific types of people, power and control over the information that we are sharing, simply because of lack of time or lack of interest, or simply, basically mostly about lack of time in the ability to parse all the types of information that come in. Since we exist, we have found figures, information gatekeepers, that acted as curators of all the raw information coming in into what we want to hear from them. We have journalists, we have politicians, kings, any kind of control or power figure was in a way our own information curator and gatekeeper. Now, we have always had certain types of mechanisms of trust that we know about, that we can recognize because they are mechanisms of trust between human beings. We have, codified sociological, psychological reasons why we know we can or cannot trust, or to what extent we can trust another human being with our information. Sometimes we do well, sometimes we don't, but we know humans. But the main problem today is that humans can't manage the information that we are receiving. This is a pretty obvious thing that we all know intuitively, but we also have some numbers that kind of put it in perspective. Welcome to the internet. So there was a study done in 2005 that tried to measure how much raw information we receive versus how much time we actually have to consume it. It was done in the US, and it compared 1960 with 2005. And what the researchers did is they looked at how many minutes of content are being produced versus how many minutes of time I as a human being have to actually absorb that content. In 1960, the numbers were 82 to 1. So there were 82 minutes of content produced for each minute I had of time to actually absorb it. That is, a relatively manageable number if we have human gatekeepers, curators that can help us make sense of that. In 2005, that number jumped up to 884 to 1. There's the one down there. Slightly more than 14 hours for every minute of time I have to dedicate to actually absorbing information. It's actually, that is the situation that we found ourselves in 2005. We're talking 12 years ago. Already the number of raw information coming in was humanly unmanageable. So what happened since 2005? YouTube didn't exist in 2005. Facebook became a thing, I think, late 2004. Instagram, Twitter, Snapchat, Reddit, and all the cat gifs came out after 2005. And we are talking about platforms with billions of daily active users creating billions of minutes of content. So the situation in 2017 is much worse than in 2005, and we don't know what will happen next. So obviously, oops. Going back, obviously we need a system, an automated system to help us to make sense out of it all. Automated systems like algorithms. Now I'm using the word algorithms to signify a bunch of things. We will go through that as well. But we needed, and we need still more each day, automated systems to make sense of the information that we are receiving. Filtering it, sorting it by relevance, giving us recommendations, helping us with, when we search for something and so on. Even just simply asking questions of it. So we entrust algorithms with our sanity. But the question is, can we trust algorithms the way we trust human beings? Fundamentally, the things, to answer that question, we have to think about three things. How are algorithms made? because we know how humans are made. Who makes them? Again, we know that one. And what are the effects on the information we receive when algorithms mediate that information? So the first question here is, what are algorithms? And this is kind of like the big one. And many times I get the questions from people like, hey, what is an algorithm? My friend Moore this morning had a great analogy, which is an algorithm is simply a recipe. It is a sequence of steps to get you from A to B with a certain goal. It doesn't have to be code. It doesn't have to be, it's not a computer language, definitely not magic. Algorithms are a process. The definition, the official definition, is a process or a set of rules to be followed in calculations or other problem-solving operations. So already you see that anytime we talk about algorithms or algorithmic processes, we kind of talk about everything and nothing. When we talk about computers, we mostly talk about many systems of computer code connecting to take you from point A to point B, but there is no specific algorithm entity that we can refer to, that we can understand even that easily. Another really quick notion here is how algorithmic processes get to a certain result. We know how humans do it. We know about insight and intuition. We also know that most of the information curators that we choose to trust, like journalists, come from humanities. They come from years and years of study around context, around how human elements, how humans interact, and what are the sociological, psychological aspects of events. All of that contextual cloud doesn't exist in a computer. What we have at the basis of a CPU, we have a very, very, very fast switch flipping machine. The only thing you can do is turn a number from 0 to 1 very, very fast, lots of numbers per second. So at the end of the day, any algorithm that we write that needs to help us understand how to filter a type of information, how to understand what recommendation works for us, at the end of the day, we can't count on insight. We can't count on a gut feeling. We need to be able to reduce it to basic algebra for the computer itself. That is, there is no qualitative judgment on this. It might be even better, but it's definitely different, and something we, as human beings, don't do. And this is the most important part, is that every time we talk about algorithm, there is not ever one single piece of code or one single 1, 2, 3 step like in a recipe. Usually algorithms are algorithmic processes that are built upon and built upon and built upon until they do the thing they need to do as well as is needed. Many times, the case is that even the programmers themselves don't know exactly what an algorithm does, which I find equal amounts hilarious and horrible. On one hand, because there are certain pieces of code, usually called libraries, that are easily reusable because they help you just avoid writing a specific type of code because somebody already did it. Adding all of those libraries and adding different types of code that somebody else developed adds into my algorithmic process a lot of unknown bits of decision making that somebody else took and I didn't. Also through the concept of A/B testing, which is mostly the way that all algorithms today get refined. A/B testing means, is solution A better than solution B? I don't have to choose. I will just test them both on a huge amount of audiences and see which one performs better. Which means that we can, the practice is just throwing different types of solutions out at people. Google does it all the time. You never know, or obviously Amazon does it, Facebook does it. Always tiny tweaks to the platform that you're seeing, and then they're basically gauging what type of result they get, whether the engagement is higher, the clicks are more relevant, and so on. What happens is that the proliferation of A/B testing also takes us further and further away from having an actual senseful way of deciding how an algorithm should act on a certain type of information. Algorithms always do have a purpose. Every single algorithm has been written by someone, is owned by someone, and somebody will most definitely profit from it in a certain way. Now, not all algorithms are profit-based, but the ones that we use day to day are. We talk about Facebook or Google or any kind of service that we use that actually curates information for us. All that information is, at the end of the day, meant to provide a certain profit for a for-profit company. So what we know is that the owner wrote an algorithm that ultimately will bring the most money into the company. And we also know that whoever wrote it with that indication in hand. We also know that people bring their own implicit biases into anything they write. We also know that most of the developers are white male from somewhere in the United States or Europe. So there is also huge bias on tools that are used globally. For that reason, algorithms are never neutral. There is a myth of efficiency and a myth of neutrality around using automated tools that is literally never there. It is being taught that way. Usually in universities, that is changing, but it is being taught that way. Coding and functions are meant to have the greatest efficiency possible. Every single time I choose, a certain function over another function, I make a choice, and it's a conscious choice, or sometimes an unconscious choice that comes from possibly from my big old bag of implicit biases. And the worst thing of them all is that algorithms are completely hidden. We cannot, by law, most of the cases, see how they work and why they do what they do, mostly because they are trade secrets. They are considered, the algorithms for Google search are Google's main intellectual property that makes Google into the giant that they are today. They're complete black boxes that we cannot look into, although some academics, some researchers are finding ways to unbox those black boxes today. So the thing is, we use algorithms every day. We can't know how they work by definition. And the main three problems here is that algorithmic information filtering is biased, for sure. It does strengthen prejudice because algorithms learn from how they are being used. And there's a great example here, but I don't think I have time for that one. But I will send you some links after the talk. And it also self-amplifies. If we think about the first page of Google results, there is a huge difference between clicks on the first page and the second page. I mean, you can do a raise of hands of how many people actually clicked on the second page of results on Google, and I would lower my hand. So all this means that, trust mechanisms have changed fundamentally. But so what we need to do now is we need to define what algorithmic trust would look like. That is our next step, because fundamentally, automated systems aren't human systems. They are usually a mix, but there is a huge component of automation that we don't know enough, and we haven't codified systems of trust yet. The three main areas are defining ethical frameworks for utilizing algorithms, defining legal frameworks for using algorithms, and working strongly on transparency. And I'm very happy that I will be followed by a couple of colleagues that will focus specifically on what ethics and algorithms mean. So at this point, I can also say goodbye and thank you. I added my favorite GIF there because usually I put a lot of GIFs in my presentations, so people will be like, where are the GIFs? There you go. That's the link to the presentation, and you can find me on all the socials on Geber. And if you want to know, this all comes from a thesis that I wrote that you can find on my website at tin.fyi if you want to go deep. Thank you.